This lesson will show how to use the free online graphing calculator linked below to determine normal distribution probabilities. A data set of test scores is normally distributed with a mean of 72 and a standard deviation of 8.2. Determine the probability that a randomly selected test score is in the given interval. Give the answer as a decimal to 3 decimal places and a percent to 1 decimal place. To determine normal distribution probabilities on the calculator, we use a notation shown below where we enter normal CDF, and then in parentheses we have A, B, the mean, the standard deviation. This gives us a probability that X is greater than A and less than B. Entering the mean and standard deviation are optional. If we leave them off by default, the mean is 0 and the standard deviation is 1, which means the X value would be a z-score. For part A, we're asked to find the probability that X is greater than 75, which means 75 is a lower bound for the value of X, or the value of A. We'll have to exaggerate some large positive value for the value of B for the upper bound. So going to the calculator does have quite a few features. We're only using the bottom calculation screen. So we click in the cell that's titled Type an Expression. We enter normal, CDF, open parenthesis, and again, because we want the probability that X is greater than 75, the lower bound is 75, I'll exaggerate a large positive test score, for example, 99,999, the mean, which is 72, standard deviation, which is 8.2. Close parenthesis, and enter. To 3 decimal places, the probability is approximately 0.357. which is equal to 35.7%. For part B, we're asked to find the probability that X, a randomly selected test score, is less than 85. So because we have X less than 85, 85 is now going to be the upper bound, or the value of B. We'll have to exaggerate some low test score for A, the lower bound, for example, negative 99,999. So going back to the calculator, click in the Type an Expression cell, and once again enter normal, CDF, open parenthesis. For the lower bound, we'll use negative 99,999, the upper bound is 85, the mean of 72, standard deviation of 8.2, close parenthesis, and click enter. To 3 decimal places, we have approximately 0.944. which is equal to 94.4%. And for our last example, we want the probability that X, the randomly selected test score, is greater than 70 and less than 90, which means that 70 is a lower bound, or A, and the upper bound is 90, or B. Click in the cell, type in normal CDF, open parenthesis, 70, 90, 72, 8.2, close parenthesis, enter. To 3 decimal places, we have approximately 0.582. which is equal to 58.2%. Before we go, let's go back to the calculator one last time. For reference on all of the features of the calculator, you can click the Help button in the upper right-hand corner. In our case, to find the normal CDF function, we would click Function Reference and scroll down to Statistical Functions. And here we find the normal CDF function as well as several others. So you might find this help a good reference. Thank you for watching.